Okay, on Friday, we worked with pi, which was great. Both kinds of pi, the mathematical constant and the tasty treat. We used the video that I'm going to show you again in a second to find out how much area, how large of an area a can of whipped cream covered, and then you use that to answer a couple of questions. Right? Let's take a look at those questions that you did on Friday and today. Okay. We found out how much does whipped cream cost per can. Right? We knew 3 for $5, so we worked that out to $1.67. How many cans to cover all 8 pies? How much would those cans cost? How much whipped cream? How much does the whipped cream cost per pie when we divided by 8? And then, were there any pies that required more than 1 can of whipped cream? Okay. Everyone remembers those, has a pretty good idea of what we did. You explained those to me. Today we're going to use that same can of whipped cream, that same video, but you guys are going to answer something else for me. Okay, we're going to see how well you understand that formula for area of a circle. Okay, so let's take a look at this video one more time. Okay. Alright. Tell me this. Were you able, by that video, by the video we just saw, were you able to determine how much area a can of whipped cream will cover?
Yes.
Okay. On your whiteboard, tell me these two things. Number one, how much area did it cover with correct units? And number two, how were you able to figure that out? Okay? Give me a sentence or two or an explanation of some kind, mathematical sentences, something that explains to me how you found how much area that whipped cream covers. Okay? Go ahead, take 2 minutes. Well, take a look at the ruler there. Can you tell based on that? Okay. Kaylin's question is, did you use centimeters? And my answer is, take a look at the ruler in the video and you tell me. Does anyone need a little more time? Take another 30 seconds. Yes, we're going to. Why? We'll forget the pie one for a second. If just the whipped cream covers an area of 300 or 630 centimeters, and then you change that to be square centimeters. Why square centimeters? Why'd you change it? What were you thinking? Why not just centimeters? Why couldn't we express it just in centimeters, the area? Hold on to that question. I'm gonna throw that out to the class. Does anyone need more time?
I just need to write it and read it.
Okay, you can explain it though? Okay, Michael, can you explain it? Even if it's not totally written down, yes? Okay, Esmeralda, we're okay? Alright, let's start with what area did you come up with? And it seems there were two different answers that I saw, but you're both pretty close, because we're estimating based on what we saw, right? Rachel, what did you get for area?
600 square centimeters.
600 square centimeters. Anyone else get a different answer? Okay. Ezzy, what'd you get?
615.
How'd you get 615?
Since it was like between 20 and 21, you go in the half form.
Okay, so you found 30 times 20, 30 times 21, and then found in between, or did you multiply?
I did 20.5.
Okay, you used 20 and a half as your height. Did anyone use 21? Okay, and what'd you get? 630 square centimeters. So we're all right in that same area, right? Because we're unsure, right? It wasn't exactly a straight line. It was somewhere between 20 and 21 centimeters for height. All right, why were we able to figure that area out? How did you figure that area out? Okay. Give me your explanation of how you found that area there. Let's pull your name at random. Give me your explanation of how you found that area. Rachel.
I multiplied 20 and 30 centimeters, and I got 600 square centimeters.
Okay. You multiplied 20 by 30, and you got 600 square centimeters. Okay. Why were you able to multiply 20 times 30?
Because if you cut it, you get an array, so it'll be...
Okay, so you're saying if I marked off those 30 and those 20, and we played it out, we would get square centimeters, and it makes an array. Okay. Why does that work?
Because...
Suppose I sprayed the whipped cream, I didn't mean to cut you off, but suppose I sprayed the whipped cream in a different shape. Suppose I just sprayed it all over the paper, right? You guys would have enjoyed that a lot. Would I have been able to find the area so easily?
No.
Okay, so Rachel, what were you going to say? How come?
Because if it's an array, you can just count the squares.
What makes it easy to find that array? You're right. I'm trying to pull something out of you.
Oh, yeah.
Right, suppose I sprayed the whipped cream and it looked like this. It looked like something like that. Would I be able to find the area easily?
No.
No. So why am I able to find the area easily when the whipped cream looks like this? Does that help, Michael?
Yes.
Bianca, how come?
Because you could just do base times height, and for that you'd have to find all different heights and stuff.
Okay, why can we do, you're right, base times height, we're getting closer, equals the area here. Why? Why does the base times height equal the area when the whipped cream looks like this?
Because when you said it makes an array, you could just count the squares.
What shape is it? What shape is it?
Rectangle.
Rectangle, okay, because we've got a rectangle. If we didn't have a rectangle, it would make it tougher, right? Because we know, when measuring the area of a rectangle, if we mark off the centimeters, inches, the length on both sides, and we draw those lines across, we end up with square units, and that's our area, right? We've also figured out area of triangles, area of parallelograms, and area of circles, correct?
Mm-hmm.
Okay, we found out why each of those formulas work, and we've gone forward. Okay, here's what I want you to do today. Here's going to be your job. Okay, in your groups, okay, and I may move one or two people around. You guys have 4 and you have 2, so I may trade one of you guys to this team over here. What I'd like you to do is, suppose I sprayed that can of whipped cream, instead of in a rectangle, suppose I sprayed it in a circular shape. Okay? I would like you to construct on the paper, I'm going to give you a large piece of paper, I would like you to construct on that paper a circle that is exactly the same area as that can of whipped cream. Okay? So let me say that one more time so you know what you're going to do. You're going to construct for me, you're going to actually make for me, a circle that is exactly the same area as that can of whipped cream. Okay? I don't care if you use 600 square centimeters, I don't care if you use 615, I don't care if you use 630. All of those should be pretty close. Okay? And luckily, I have 3 cans of whipped cream left over from Pi Day that I've kept over the weekend in the refrigerator. So, I will choose at random 3 of those 5 circles, and we will actually spray the whipped cream on your circle to see if you are correct. Okay, so be very careful. In order to help you out, everyone has a calculator. You may certainly use it. I encourage you to use it. I also have for you some pieces of string. I'm not going to tell you what they're for, but if they help you out, that's great. I'm going to pass out to each group a measuring tape, or a couple of measuring tapes. And I'm going to give you a pair of scissors in case you need to cut that string to a different length, in case. Okay? Are there any questions for me on what you're going to do? Okay? I'm going to give you, let's say, about 10 minutes. Okay? 10 minutes. Make sure you're discussing. If you have any questions and you need help, discuss them in your group, but I'll be walking around to help you out, and I'm certainly willing to give you some advice and nudge you in the right direction, but I really want you to try and do this as much on your own as you can. Okay? Questions? Okay, start discussing. I'm going to pass out the items that you need.
Okay. So what we you can start discussing.
All right, over here. Let's see. Pick a number 1 through 4. Nope. Nope.
3.
Yep, you're traded. Over there. Okay, did any group not get a pair of scissors?
Alright.
But we need to try to
Alright.
String.
So if
What's the radius?
that is what are we gonna use? 21 or 200?
I think we should use, but there's 20. We gotta find out. Wait, I found out.
Here's your paper where you can construct your circle.
Alright.
Okay, here's your paper where you can construct your circle.
So if it's put mine on the bottom of this. Radius squared. So what squared equals what squared equals radius? Well, can we like do it?
Okay, here's where you need to construct your circle.
600 divided by 5. Yeah,
Use point inside. Equals 191.080.
So 600.
Bianca, this is Pascal speaking.
191
Divided by 2. Oh yeah, that's how we do it.
Yeah, isn't it? We have to make it here, push it to the side. Radius squared times
Okay, what do you think, you guys?
what number radius?
What are you thinking?
Let's try. Wait, are we using 600?
They got nothing?
600.
Okay, well let's start with what we know.
Wait, in these
What does the area of the circle have to be?
no, we're using 600.
600. So why don't we write that down so we have
Divided
that?
by
Yeah, whiteboard's fine. 600 what? Okay.
yeah, that's far off.
Now how can we work that back into a circle? So we need the area of that circle to be 600 square centimeters, right? How can we work that backwards? What ideas do you have? Why don't just on your whiteboard, let's go ahead and draw a circle. And let's label that, let's pretend that the area of that circle is 600 square centimeters. Okay. Now, could I just right away draw? Okay. So what do I have to do to be able to draw that? If I had the diameter, could I draw the circle on there? I would know how far across that circle is. Would that help me draw it?
Because you need, in order to find the area of a circle, it's radius squared times.
Okay, hold on. What's Abby saying? Go ahead.
In order to find the area of a circle, you have to do radius squared times pi.
Okay, so why don't we write down that formula so we've got that?
Pi divided by something.
How do you find the circumference? That's a good question. How do you find the circumference of a circle? Okay, why don't you guys are starting to get somewhere now. Why don't you talk a little bit and see if you can come up with some way that we can construct that circle, okay? Good, you guys are on the right track.
So maybe we can
Alright, what are we thinking here? What do we have?
times 0.14.
Circumference.
Radius times radius.
Okay, alright. Now, hold on.
Radius squared times pi
1,000
for the area.
Okay, I'm gonna bring you these papers. Anyway, let's start with, we're talking about the radius squared. What do we know? What do we
Maybe
know about
30
the circle?
because 30 is big.
You're getting closer.
Okay.
And if I can make this.
Hold on, before we even get to the squaring radius and all that, what do we know about that circle right now? Area of that circle is
getting
gotta be
close.
600, 630. Okay, so let's write that down, we know that, right? Area of that circle has gotta be 600 or 630.
Circumference. So backwards.
We need 630.
Pi. Find the radius of circumference divided by
Okay,
pi.
now, how
Pi
do we know
divided by
that circle has
circumference.
that area?
Okay. We don't have the circumference.
Maybe it's 13.
How do we find the area of a circle?
I'm confused now.
Okay, so radius squared of the circle times pi has got to equal.
Oh yeah, you need the diameter.
Can we work with that?
Have to have the diameter.
Do we have some good ideas? Okay, so what do we know so far? That
600 divided
area's got to be 600 square centimeters and
191.
what?
So 191. Just 191.
Radius squared times pi has to be 600.
Okay.
Does that,
that
Taylor,
would
are
be
you okay with that? Does that make sense to you? Okay.
Wait, what did you just divide it by? Divide it and then press the square root button.
Alright, what are we thinking over here? How are we doing? Okay, how did you guys need me over there?
What is it? Should I just look how close I was to it? Are you serious? Off by like
Okay, you need to
100,000.
Oh, yes.
Okay, but now, okay, I'm gonna do yeah, so the diameter
Okay, you guys, I don't see you working.
Square root.
Are you ready for strength?
circumference.
You know what you're going to do with this?
That would be 100
Or no?
that would be 154.
Then you need to be working on the math. The string is the least of your concerns right now. Right now, find out what you're going to do with it.
So let's do it here. So that,
What do you?
so what we would do is
I found it out.
that would be 600. It's not 100
Yeah, it is.
The area of
That's 600 centimeters.
We need 154 centimeters.
Yeah, we need 154 centimeters. So
We just got cut off.
oh wait, how long is it?
It goes to 150.
We need more.
Go ahead, Clinton. I'm listening.
Yeah, so well,
This is 60 centimeters.
So
So
what
the
we
diameter
don't
is going to
do
be
with
49.
that?
So let's
What do you? Stop.
here, get a marker. Mark
Before
it
you,
at
first of all,
49.
you're not talking to your partner. So you're just typing things into the calculator. He doesn't know what you're doing, right? You need to talk
Then
this
mark it at
through.
the.
What were you thinking? What are you doing?
so that goes around that wide, and then we have to like find how to put it.
How do you know? How do you know the radius is 150? Right.
600 divided by 50.
How does that give me the radius?
Square root.
We need like somehow to
So
keep
you're telling me
it
the area of a circle is
like
4 times
still.
the radius?
Yeah.
Is 4r?
Here, wait. Let me see.
Or no?
This would probably equal around
around 154 centimeters.
How do we find the area of a circle?
A little bit farther. My string would kind of be too small. Yeah, it is.
Okay, and so when you do for your circle, when you do the radius times the radius times pi, what are you going to get? What's
Yeah,
the
because our circle's right like
okay, and what's the area of the circle?
that right now. 13.8.
And a pencil.
What's the area of our circle?
I don't know why they wouldn't like continue this.
Okay, so if we multiply the radius of our circle times the radius of our circle times pi, we're going to get.
Somehow we need to like get it to stay there.
The radius of our circle times the radius
I
of our
mean,
circle
making
times
a
pi.
circle isn't as easy as it
Okay, and what's the
sounds.
area of our circle?
Maybe if we like put that
asking for help.
there.
Okay, so let's write down what we know on the whiteboard. Okay, write that down.
Robert,
And let's
did
see
you
if
put
we can
that
work backwards then to construct our circle. Okay, good. I see tape measure. What are you thinking?
We found the diameter, circumference, and radius. We just
Okay, how'd you find it? Guessing and checking. I'm a little nervous by that.
we did the 600, and then shift, and then that, and we round that.
No, hold on. Wait, you did 600 and you did what?
Shift, then that.
So you found the square root of 600.
Yeah.
How does that help you?
It shows us the radius
It does?
without square.
Okay, let's step back. Here, I see radius squared times pi, right? Okay, what is that? No, but what is this right here? Radius squared times pi.
The formula to find the area of a circle.
Area of a circle equals radius squared times pi. We'll write it that way, okay? All right, what's the area of our circle?
600.
Okay, it's going to be 600 square centimeters, right? So can we agree that 600 square centimeters is the radius squared times pi?
Oh wait, Phoebe, that is that, but it's also multiplied by pi.
Okay, can we get rid of pi here and make it just the radius squared? How would we get rid of pi over there? From?
24.
Well, forget the 24.5 for a second because we're not sure. That was just the square root of 600. We're going to forget that for a second, right? We want to get radius squared by itself, right? We know that if we multiply pi times the radius, we'll get 600, right? Okay. Can we take pi out of that equation a little bit? Can we get rid of pi? What if we didn't multiply by pi here, right? And we just had the radius squared. Okay. It wouldn't equal 600 anymore. What would it equal? Say it again.
600 divided 3.14.
Yeah, we would have to divide, if we divide by pi on this side of the equal sign, we also have to divide by pi over here, right? So this would be 600 divided by pi over here. Okay? Do you see, right? You okay with that? Does that make sense to you guys? Okay. And that would give us the radius squared. Can we work with that then? Does that make sense? Yeah. Okay, good. Go ahead. I'm going to come back and check on you guys. Okay, how are we doing here? Are we getting somewhere?
0.75.
Now, hold on. There's nothing on your whiteboards here for me to be able to look at and make sure you're on track. Show me everything that you've done so far. So when I come back, I can follow.
600 is radius. We need to get to 600. Okay. Instead of 33, this might be the diameter. Right. 13.82.
Okay, good.
My nickname is Baz.
Which is pretty close to the area we're looking for, right? Okay. How did you find 14 then? That's okay. You can say guessing, Jack. That's fine. Did it work for you? Okay. If that works, that's cool. Okay. Now, how are we? Now, hold on. How are we drawing? We're having a tough time drawing the circle, right?
Yeah.
That's good. You found 14 times 14 times pi is going to give you 615 and change, right? So you're pretty close to the area we're looking for. Okay. Now our problem is how do we draw that, right? Okay. Now, can we use the string in some way?
Yeah.
Okay. What were you thinking for the string?
We were thinking of like putting it around, but then it wouldn't stay still and stuff.
Okay. So you thought about maybe finding out the circumference of the circle, putting the string around the outside, and then kind of tracing that. But the string won't stay in a perfect circle for you? Is that the...
Yeah.
Okay. Is there another way we can use the string?
Yeah, we could make like we could have it put in the center, like one of the edges, and then we draw around it on the edge.
Try it. Let's see. I'll come back. I'll step back. Try it.
Okay, so if we're gonna,
When I left you. Okay, so let's get you back on track. So what do we know so far?
and then cut off
Right.
14 centimeters. So yeah.
Okay. So 600 centimeters squared equals pi times the radius squared, right? Okay. Now where are we going from there? We're not sure. What'd you try?
As long as
Okay, when you did 600 divided by pi, you got 191. Exactly? Okay, well, why don't we go a couple more decimal places? 191 and 800. Hold on.
a little.
Okay, so let's go with 191 and 800ths of a centimeter. Okay. Now, take a look at our formula here. We did 600 divided by pi here. What do we have to do here?
Right there.
Now hold on. If we divide this by pi, what do we have to do with that? What's this? An equal sign, right? Think about our hand balance. It's got to stay. Whatever we do to one side of that hand balance, we have to do to the other, right?
Yeah, I guess.
So if we divide this side by pi, what are we going to do with this side? Divide by pi. So pi times the radius squared gives us
So
that.
then we don't have to.
What
But
is
then we don't have to
divide
use
by
this.
pi? It's just going to
But
be.
wait, no, keep that.
Why do we have to use that then?
So this, you're telling me that right there
Better because we're gonna
equals
have to go in a circle and.
the square of the radius, right? If we multiply the radius times the radius, we're going to get. Okay. Now, can we get that so it's just the radius by itself, not the radius squared? No. It's not the radius times the radius. Or it's not the radius plus the radius. It's the radius times the radius. It's squared. So dividing by 2 isn't better.
Put it right on this knot.
How would we find the opposite of squaring something?
Yeah, put it right on the knot.
Unsquaring it, yeah. Okay, what is that called? When we unsquare something. Think to the Pythagorean theorem when we're talking about that. And we use a key on your calculator. It's the square root, exactly. The square root is going to give you the opposite of the radius squared. Okay? So are we okay? Okay, I want everyone to stop for a second. Stop for a second. You guys are in really good shape back there. I like what I was seeing. How are you guys doing?
Good.
Pretty good?
Yeah.
Do we have a circle or not quite yet?
Yeah.
Yeah, you have a circle on the paper.
Well, no, but we have.
But you know what, okay. How are you guys doing? Okay, how close are we to having a circle on the paper?
About 3/4
Three-quarters of the way, I like that, okay?
We're doing good.
Actually, you're doing well, but you're just, what? 2 millions? Off what? Oh, you're trying to guess and check?
13.82.
No, we got
13.82 if you rounded 14.
600.
Okay, hold that. I'm going to come over and work with you guys in a second. Can we say 5 minutes?
Yeah.
We're going to say 5 minutes, okay? 5 minutes, get a circle on your paper for me, and we'll go from there. Go ahead.
How do you
All right, so where are we? When you say you're 2 millions off. Okay.
Do you want me to talk now?
Okay, so now where did you get that number? 13.823. Okay, explain to me how you work backwards. That's good.
Come here. Put a circle.
Right?
We're not ready to do a circle yet. But this is
Okay, let me ask you this.
about what I
Right, you guys are coming up now, using that as your radius.
This is
You're coming up with
close
almost,
to
like you're
so
that close to having
little.
600 square centimeters, right? Was my whipped cream exact to the millions, please? when I sprayed that can of whipped cream, was it exactly a million place in my area? So do you think you can use that? Okay, good. Now draw me a circle.
I'm going to pull a 86. Okay, so what we have now is, this is 598, so that's 86, so let's press this around. Now, how tall are we going to make it? Someone hold it here. Right here. Wait, Rachel. How do we
Alright, where are we here?
the diameter? Wait, right? That's the diameter.
What did you do?
Would the
Walk me through
diameter
each
still
step.
be how tall it is? Yeah, it would. So wait, should we like mark a line in there? We would do 27.
You said they were doing that.
Yeah.
Okay. So what did you guess in chat? What did you?
We found the area
And then it was like right there.
and 600.
Okay.
So
And then you did what?
then we're trying to find that this is the radius.
What is that number there?
95.50 or 95 and 50 and 100.
Okay. So what is 95 and 50 hundredths? What are we doing with that? Why are we multiplying by 2?
Because 95, well, we're gonna 95.50 times pi times 95.50.
Okay, but is that what you did here? Did you do 95 and 50 hundredths times 95 times 50 hundredths times pi?
Yeah.
You did? Because I see 95 and 50 hundredths times 2. Is that different than 95 and 50 hundredths times 95 and 50 hundredths? Yes? No? Peter? What are you thinking here? What was your mistake here? What was your mistake here? When you square something, you multiply it by what? By itself, right? Here, you're not multiplying by itself, you're multiplying by 2. Do you see your mistake? Okay, 2 minutes! Okay. Try not to cut my measuring tape.
We're trying to make a circle that is like the same area as when you spray the thing on paper.
We're trying 21 by 30.
About 21. So we're doing
Wait.
No, I measured it. Yeah.
First, make sure. Tap 21. I mean 20.
we're doing 14 by 14.
Now make sure that it
14
touches
times
that.
14 times.
Okay, so how did we get that? That's cool.
20 inches of diameter.
Jamie, you need to
Well, how'd you
rotate your
get the
finger.
diameter?
Yeah, Jamie. No, Jamie, because you're
How'd you
holding
get
it
the diameter?
stiff, and the string is right here,
You found the
Yeah,
radius
it's
of
gonna
14
go.
and it's stiff, and
And
it's
so
like
you use
that.
And you did that times
That's
pi.
where the tape is not good because then it will
now
just
that's your
hold it into that place and it will
Now you're
be.
trying to make it good.
No,
Okay, love it. How are we doing here?
There you go.
Good, alright, it's cool.
Well, does it have to be exactly, or does it have to be something like this?
It would probably have to be.
1 minute!
it's okay. It was close. But I've got an idea. Wait, doesn't the string have to be connecting to this? Tie it. Don't tie it too much. Yours isn't a perfect center from the middle. It has to be right out the side and that side. Don't just draw a circle. Here, it's to be 87. Here, 87 right here. Now we need
Hurry up, we need a circle.
no, that's a circle.
Okay, you guys have a circle? No, don't cut it. That makes the whipped cream. Little leeway for me is good.
I made a perfect 600. Except it's not really circular. Anything, this would be 600.
Well, what do you measure?
600.
Because again, I see no work on those boards. I can't help you unless I see what you're doing. Okay. everything you do, you need to write down for me so I can follow your thinking. I can't help you if I don't know what you're thinking. Okay, so where are we at? Okay, time's up. Everyone back to your seats, eyes up here. Ezzy, have a seat. Okay, some good thinking going on. You guys were coming up with some good ideas, and some of you even came up with ideas to use that string for ways that I wouldn't have thought, but we're right on the money, so that's good. Let's talk about what we know so far. What does the area of our circle have to be? Okay, Adam, hands off the calculator. Area of our circle has to be what in order for the whipped cream to cover it perfectly? Rob, what does the area of our circle have to be?
600.
600 what?
600 squared.
Area of our circle has to equal 600 centimeters squared, square centimeters, right? Okay, are we all okay with that? Okay. How do we find the area of a circle? How do we find the area of a circle? Okay. And you can think back to the lesson where we had last week, we took our circle, we cut it into pie slices, we made it as rectangular as possible, right? And we found that that's the radius, and that's half of the circumference. And we ended up with our formula for area of a circle was what, Timmy?
Radius squared times pi.
Pi times the radius squared, or radius squared times pi. And we know in this case that's going to give us 600 square centimeters, right?
Yeah.
Okay. Now, from this point on, there were a couple different ways that you guys went trying to find the area of that circle. You guys used a guess and check strategy back here, right? Okay. And you plugged in different numbers, and what did you come up with?
615. We do 28 is our diameter.
Well, okay. How did you get there? From this point on, what did you, when you guessed and checked, what did you come up with?
14 times 14 times.
Okay, so you said if the radius equals 14, okay, that 14 times 14, someone plugged it in on your calculator, was 14 squared,
96.
would give me 96 times pi,
196.
196 times pi, and what would my area be there?
615.40.
Okay, so if our radius is 14, then our area for this of the circle would be 615 and something a little bit more.
Yeah.
Okay? And that would be square centimeters, right? Now think back to the spraying of the whipped cream. Okay? When I sprayed my whipped cream, is that a reasonable area? Sure, we were somewhere between 600 and 630. So would that work for us? Yeah. Okay, so their guess and check strategy got them to a radius that they could live with. Okay? Did anyone else do it differently?
Oh, well.
Okay? How did you guys find the radius?
We went backwards.
Okay, how'd you work backwards?
600 divided by pi.
600 divided by pi gave me what?
Oh, 191.0828026.
Okay. So if we divide both sides by pi, we would end up with the radius squared equals 191 and 800ths and an extra, right? And then how did we find just the radius?
Oh, we found the square root of that.
Okay, and that gave you what?
13.82327033.
13.8 something, right? Okay, pretty close? Sure. Okay. Did anyone get a different radius? Now, from here, again, once we got to this point where we found the radius, okay, my groups had two different ideas. Okay? The first was to find the diameter, which would be double the radius, and then find the circumference and take your string and make that circumference into a circle, right? Okay? This group back here, I saw you doing something else. What did you guys do?
We had the diameter, and we put the string in the middle of it, and then we cut it our 14 centimeters, and then.
So you had your string, which was 14 centimeters.
Yeah.
Someone held it in the middle,
Yeah.
right in the center of the circle, and then you put your pencil on the outside and swung that string around until you had a circle. Okay? Would that work?
Yeah.
Sure. So we've got two great ways of making those circles. Okay? All right. Sometimes I give you an exit card at the end of the day where you've got to turn it in before you leave. I don't have time for that, so I'm going to give you an entry card. Okay? Your homework tonight, I'm going to give you an index card. Tomorrow morning when you come in, okay, tomorrow in the beginning of class, you're going to hand me that card with your answer so that I can make sure that you understand what we did today. And if not, I can work with those of you that are having trouble. Okay? So here's your card for tomorrow, what I want. Suppose that a can of whipped cream didn't cover 600 square centimeters, but instead it covered 250. A mini can of whipped cream. Okay, mini whipped cream. Okay. What you're going to tell me is, what would the radius of that circle be? Okay? Everyone okay with that?
Yeah.
So what would the radius be if that's the area of the circle? I'm going to give you an index card and you're going to work backwards. Before we do that though, those of you that have circles, we need to see if you were accurate, right? So, okay. Let's see, you guys had your circle first. Okay? If you would like to see, gather round. Let's see how close they came.
That one quarter might be a little bit off.
Well, we'll see. Okay. Michael, come back. It's your circle, don't you want to see? Okay, let's see how they did. How'd they do?
Good.
That was really good, wasn't it? Okay. Does anyone else have a circle that we need to check? Okay, go ahead, go get yours. That was an excellent, right? You guys were really close. Nobody's eating the whipped cream now. Okay. Okay, here we go. How'd they do?
Good.
Awesome. Anyone else have a circle? Go ahead. Okay. Okay, here we go. Last one.
You have to use up the pen somehow.
How'd they do? Good, all right. Excellent. Okay, have a seat. I'm going to pass out index cards, and then you guys can start your entry cards for me.